All right. Hey, everyone. Welcome. Good morning, good evening, good afternoon, wherever you're at. My name is Deb, and I am heading product at Infineon, a lean data streaming company, or event streaming company, I should say. And today I'm going to show you a couple of demos that do what the talk is about magical data flows. So I'm going to build some data flows live. Obviously, a lot of the code is written. So let me just share my screen and we will go through it one by one. All right, you should be able to see my screen now. And I'm just going to begin by going through what we are going to do. There are a couple of demos that I have planned, and things are going to feel like you are drinking from a fire hose a bit because Timo, as he went to the GPT and got this to be the radioactive talk of this conference, because of the Hulk analog. I felt that maybe it's apropos that streaming is kind of nuclear, kind of radioactive. If you can harness it, there's a ton of value to be gained, and obviously our experience with it is obviously a degree of complexity and so on. So what we are going to work with is a single system, and I'm obviously wearing my Rustacean T-shirt, if you will. I'm going to work with Fluvio, and we will see some code. And I'm going to be using stateful data flow. So let's get to it. The first demo, there are two demos that I have planned. The first one is called Digitransit, and Digitransit basically is shout out to folks in Finland. This is the transit system that is running in the city of Helsinki, and you can connect via MQTT to this system and capture data that they make available. So this is live data. We will look at the vehicle positioning data. There are a bunch of payloads, as you can see, and the descriptions of this data is here. So let's get things started. First things first, I am in this directory. I'm just going to start a Fluvio cluster, and that's going to launch a local cluster on my system. And then I'm going to show you some code that I'm going to run. So for the Digitransit demo, what I'm going to do is I'm going to connect with the city of Helsinki. And to connect to the MQTT source, I have this YAML file that connects to the MQTT broker that is available at the URI there. And I'm going to connect to the vehicle positioning of buses because obviously there are other types, but I want to plot them on a map. I'm going to get JSON payload and I want to transform it. So you saw that there is a bunch of things in the payload. I don't want to get everything. So there is this operator, which we call smart module for unbounded stream processing. This is a package, and we have a bunch of these to essentially format data, filter data, and things like that. In this case, what we're going to do is we're just going to get specific objects or data points or attributes from that payload. So we get that data, and I'm going to run a setup script, which will do a couple of things. It's going to download this smart module to my local cluster, and it's going to download the source connector, and it's going to deploy that connector with the configuration that I just shared, and it's going to run stateful data flow. I'll come to the stateful data flow in a second, but let's just run the setup, and we will see stuff starting up as soon as I do that. So we're downloading this, gets downloaded to my local cluster. And by the way, I've got this activity monitor, just so we can monitor. There's some Fluvio stuff running on my local machine. I'll come back to it and show you how little resources it consumes. So as all of this stuff is running now, it's loaded a data flow, and you can see it started. So what it did is it started this Helsinki MQTT connector, and we can look at this within our cluster by saying Fluvio topic list, and we can see there are a few topics that have started by way of starting this connector and the data flow. So it's getting live data from the buses, and we will look at it as we look at the data flow. Let's go to the browser and open the data flow. All right, so this is the data flow that we built, and I'm going to walk through this. But right now, I just want to show you a couple of things over here. Just hide the sharing bit. Okay, so what we are getting in this data is this topic, and then we are applying various degrees of transformations. Now, you can see we are we are looking at a bunch of routes. These are the active routes of buses that are operating, and every time that they breach a certain speed threshold, we get a counter. This is a state operator which maintains state and updates it over time. This other one is showing routes, which are specific buses that are going, and this is a helper function because when I show you the data flow, you will see how we are arriving at some of these elements. So let's come to code and look at the data flow. Now, what you're seeing here is a YAML file, or domain specific language, or DSL as it's um, called, which has a few different things. So I've folded them down so that we can see what the structure of this is. This is the structure of the data flow that we are running, which has three parts. There's the configuration and the API version at the top, right? And I can open them. You can see that this is called Helsinki Stats, running at a particular namespace. And there is a configuration. We are working with JSON data, events from sensors mounted on buses. And then we have a consumer, which is going to essentially consume the data that we get into topics and process them. Now, the types and topics are related to each other. Types essentially define the data types of the object. So think about, you saw in the API in digitransit the data points that we get from there. And then I configured in the connector the data points that I want. So this is the data points that I'm getting here. I'm getting vehicle, we get a speed, latitude, longitude, timestamp, route, acceleration, and then there is the door opening sensor, which keeps giving you that information. Once I have this data, I can build transformations on top of it. So let's close this. So to build transformations, I am building a few lists here, and I'm building a count. These are all objects that I declare to process. Now, those are essentially what will go into topics and what we will visualize. In terms of services, there is a mapping demo that I'll show you with buses. So here, there are a ton of buses running, as you just saw here in my browser. There's just a lot of routes active right now, right? But if we start visualizing everything, my system would probably crash because I'm running everything locally. So what I'm going to do is I'm going to put filters. Let me just validate that I can see these routes. Hopefully we have, okay, sure, we have 10:30. Let's see, what, 40. Okay, so I think it's a peak traffic time, so we've got all of this stuff. So my code is good. Okay, and then there is this filter by door, which basically captures whenever a door is opened, and we are seeing that as a state that we keep. So if you look at the structure of this, these things are services, okay? And a service basically takes an input topic, the data in the input topic, applies a transformation operation. And if you look at the transformation operation, similar to the modular transform that we applied, these ones are using these primitives within a bounded context, meaning there is time, there is key value state, and we maintain the state, and then applies a function, and this is a Rust function. Now, you could write these functions as some inline SQL, and I'll show another piece. You could write them as Python functions. You could write them as JavaScript functions, and this is kind of like an idea of Ruby on Rails. So what is happening here is this run function. When I run the script of stateful data flow run, or SDF run, what it does is it generates the entire scaffolding. So it generates the code and everything that you need to run this project. And if I go into the project, you'll see that the functions that I've implemented here are inside the code. And so there are two parts to the system. Obviously, this is built as a Rust project because I'm writing these functions in Rust. Our core project, or Fluvio, that I'm using right now, is an open source project that is being entirely built in Rust over the last 5 years, and that's one major bet. The other thing that we see here is this .wit. So all of these types that we have implemented here are language agnostic by design. So they are all implementing, using the WebAssembly component model, WASM interface types. So you can write essentially any programming language that is compatible with WASM, and then it can compile to WASM types and then run against our system. Okay, so enough of explainers. Let me run a couple of things so that you can see what that actually ends up doing. So here in the Express WebSocket, I just have a simple web app that runs a node server. So I'm just going to start that, and it's going to start listening on port 3000. And we have like a very basic map API with open maps to map the buses as a front end. And I'm going to build that and copy this URL and open this in a new tab. All right. So now we have a map for the live data of the buses, and you can see how we are tracking the speed, and it's updating everything real time from a live data set. Let me see if there are any questions or anything in the chat. I can't see anything, but hopefully this all makes sense. Going to minimize this thing here. So this will continue running. And I'm going to start another demo or another project, which is the cars project, there to show a couple other things here. Now, while I'm doing all of this, notice that this is working with live data, and it's probably consuming less than 50 megs of RAM and minuscule CPU. So all the Fluvio runners on the system, Fluvio compiles down to a 37 MB binary, which can run on the edge. And the workers that are running stateful data flow operations to run these transformations as change services, asynchronously processing events, these workers can be deployed on the edge as well. So we are going for lean and mean. That's what you'll find on our GitHub repository. Now let's go to another demo that we cooked up. This is synthetic data that we are generating on a web server, and this will have a little more visualization to show some other pieces. So now you see same idea. There is some metadata. There is some configuration where we are getting JSON payload. The payload that we get is in the README MD. So let me close a couple of files here. And here's the payload. It's a simple payload where we get maker, model, category, color, license, fuel, location, miles per hour, and timestamp. And we get a database of license plates records, which we load. So these are the two data sets that we start with. Now that's car here, the types, and licenses. Okay, so we store that in actually license. We store license in a list called licenses, and we maintain that key value state, which I'll show you. Now we have topics that we create with maker, speeding, and we split the data based on location within the payload. We find colors, and we look at licenses to load that data and do violations. I'm showing you this to just give you a different flavor of things, and get a picture of how these things can be composed to do many different things. Like, it's super flexible. It's modular, it's composable, and it's all using a single system. It's just Fluvio and stateful data flow. So let's go to lookup maker, and here is one piece where we use this map primitive to transform the cars topic, right? And what we do with this map primitive is we add a dependency to call out to an API. So you can use this to call out to any API, and think inferencing in AI ML models, if you were talking about AI, or any API where you want to enrich data with a third-party source, and you have a data in your topic and you're enriching it from another source, you can run this function, which will call the API, right? It will call the maker endpoint, and it will enrich the body of the cars topic and write to makers. And then you have a service to find speeding cars. This is a very simple function that we're going to run. It's a filter operation that looks for cars which will violate a certain speed limit, and write to a topic called speeding. And we will visualize all of these. I've got a very simple web app, no UX, but basic visualization to show you stuff. And then in this other operation, what we are doing is we are splitting by location. So we look at the payload, and we run a function to match the location of the car, and uses the map operator again, and syncs to a couple of topics. So in the payload, if it matches Saratoga, a place in California, and Sunnyvale, and it will send it to two different topics, running a filter function. And then it takes one of these. I think it's the Saratoga ones. It could be the Sunnyvale ones, but once it's divided by location, now it applies what we call stateful time-based window aggregation or window-based aggregation, right? So it's 30 seconds. Actually, let me make it 10 seconds. So the graph populates faster. So what it does here is takes a Sunnyvale topic and then it defines a state object which will be counting or aggregating over a period of time. And then we have this window description of you're going to do tumbling windows every 10 seconds. And there are functions to assign a timestamp, partition by key, which are the colors. And then it will update the state, which means every time it sees a particular color, it will increment it, as you can see in this function. And then when the window reaches 10 seconds, it's going to run the flush where it will look at all of the numbers. This is what we call materialized views. So you look at the color, the count for last 10 seconds and capture that materialized view into the material into the aggregated topic called car colors, and then we can visualize that. The final piece is save license plates, where we take source of licenses, the one that I mentioned, and then this license plate will be stored as a key value state. So you can see this is keyed state. Think like JSON objects, like a document store, and you can see that it stores it in Apache Arrow format. So it'll basically store it as an in-memory state that can be referenced in another service. So this is really the radioactive part of it, if you will. So you save the license plate and then you can check it. Now, notice another thing when you're checking it. So you basically first load the state object that we saved in the previous one, and then we start with the cars topic. And then what we do is we basically call the operator filter map and see what we are doing here. Now, as soon as you store the data in a format that works with SQL, say Arrow or Polars or whatever, you can then write SQL to look up, and then you basically do a lookup and apply a function where if there's missing value, you put that into violations. So running this stuff is fairly straightforward. I should be. I hope to be done another maybe like 3 minutes or so. Let's close all of this so we can come back and reference what we are doing. I'm gonna go in and stop this one because I need the 3000 port. This, okay, so all you need to do here is single command sdf run, and you can do a worker. I'm gonna run an ephemeral worker and specify the port, and that will build the data flow. Now, in the connectors, I'm gonna use CDKR connector development kit to start the two connectors that will fetch the data. Now, in this case, these are HTTP connectors. So you can see I'm going to start HTTP and I'm going to get the licenses from the license API HTTP endpoint and cars from the cars endpoint. So these are endpoints that we have web services running, sharing this synthetic data. And we have now, if we say CDK deploy list, everything is happening on my local machine. Obviously, this is cloud native, can run on the cloud. So I've got two more connectors that started pulling data in. I can go to 9000, reload it. That should give me the data flow. Hopefully, we started the data flow here. Oh, geez, it's actually started in a different port. 9000 was in use already. Okay, so here's what that looks like now. So what we are getting is, sorry, I need to refresh this one. Oh, I see what happened. I'm running two ephemeral workers. Let me do this. I'll just exit from here and exit from here and start again. Okay, live demo, something has to go wrong, right? All right, let's do this. Let's push the port, and that should do it. Let me actually also start the visualizer. Okay, so now it's listening to the licenses and showing me a visualizer. As soon as the data flow loads, we get the data flow here. All right, so this is the data flow that we just built. And you can see this is the license plate state that we have stored. And then we are cross-referencing that state to check the license plate type violations. And then you can see the count by color. It just counts, and then every 10 seconds, the window tumbles, meaning it flushes the data and it starts um, doing it again. I'll just wait 10 seconds here for it to refresh. Okay, there you go. And now let me just get the web app going. All right, so you can see in this, and this is the last piece to show you, this is the raw data is at the bottom, right? You can see that the data is flowing through. And what is happening is every 10 seconds, the graph of the colors update color coded, and I just made it too large. But you can see the speeding, anything above 45 miles as the records come in goes to the speeding table over here, and the violations come in here. Um, I know this should be feeling like drinking from a fire hose. This should be feeling like it's radioactive because there's a lot that I just went through. But the cool thing is that if I go back to my resource utilization, well, all of the data flows that is running, it's I have a powerful Mac, but you can see all of this is running self-hosted and it's consuming less than 50 megs of RAM, maybe a little bit more than 50 megs. But one of them is running a real um, data set from Digitransit, as I showed you. And that would conclude my demo. Let me actually go to the studio and see if there are any questions, or maybe on the LinkedIn
No, no, it's
if
like
there are any comments.
I think we don't have questions. It's just like I think people were just impressed by how straightforward it is. At least I was.
Okay, studio.restream.io is frozen for me.
Okay, can you hear me? I guess not. Huh? Okay, no worries. Yeah. So okay, Tim, where are you watching? So I think Deb and I are disconnected. So we both are
Let me
visible
clear out some
now.
of the stuff. I'm trying to look at LinkedIn comments to see if
Yeah.
there are questions, but I have to use my phone. I'm going to clean up the
So the stack is
running
Flowio.
apps so that it
I think Deb will
allows the
definitely
stream to
share this.
typically the JavaScript operations, the web servers services are the ones that will cause some challenges.
Okay, so we'll just wait until Deb has cleaned up his memory. Maybe then he's back. So, but I think my
Let's
takeaway,
see.
yeah, our restream was pretty solid throughout the whole talks that we had so far. So this is really good. I think my takeaway is like impressive how straightforward it is to configure it. I mean, as someone wrote, like we all become YAML engineers, but honestly, if it works like this, it's amazing because I know how to do this stuff by hand. Uh, that drives you crazy. Okay,
That's
so
interesting. Am I like completely frozen or something?
yeah,
That's
you are.
it's dude, it's like lagging like crazy. So let me talk about the stack. Okay, I'll just explain what the stack is. What we have is Fluvio. It's a distributed streaming engine that we have built. We have built it from the ground up in Rust. I'm weary of changing screens, but I will go to the Git repository anyways. I'll hazard this. Uh, So Fluvio is a distributed streaming engine that we built. And as you can see, it's built from the ground up in Rust, and our other bet is WebAssembly or Wasm, and it's essentially an alternative to Kafka and Flink in one. Now, if you look at the stack, this is the bottom is Fluvio, where essentially you have streaming data that you can plug into events, and events will flow in to streaming data, or to streaming topics rather. And then you have state, key value states and watermark states, which basically um, are objects that you store in memory to be able to cross-reference back. Now, topics as an abstraction in event streaming is basically a container. It's an immutable log. It's a container of data where it comes in, events come in as a log, and the topics store the data for the period of retention. And you can define the period of retention. Typically, the default is 7. It will actually store the data on disk and it will retain it. And for the period of retention, it will be consumable, um, based on the offset configuration that we looked at. So you can consume the data on demand at will by defining from what offset you want to capture that data. State is typically, again, snapshots of data or timestamps or watermarks, as I mentioned. And then the primitives are basically operations that you want to do. And this is a system, not a stack. So I would use the word system rather than a stack. And the primitives are things that you do with the data. You map data points from different data sources. You filter data from different sources. You filter map combination. You split, you join, you merge, you make API callouts for enrichment and stuff like that, right? And then in stateful operations, you define windows, whether it's tumbling windows, sliding windows, hopping windows, whatever. And what you're doing is you're defining a time interval, and you are computing some aggregate, whether it's a moving average, whether it's a sum, or whatever it may be. The functions is what you write your business logic using. So think of these as like lambdas. So you could write the function in Rust, or I showed you examples in Rust. You could write them in Python. You could write them in JavaScript. Basically, what happens with those functions is stateful data flow generates the entire scaffolding, meaning all of the libraries, boilerplate, whatever is required for that function to build, and then it compiles to WASM binaries, WebAssembly binaries, because as I was showing in the demo, part of what we generate is WASM interface types. And then multiple functions stitched together into services becomes data flows. And you can publish those schemas or data flows and things like that as packages and functions which can be reused in other data flows. So that's like the entire system. And I showed a couple of examples. What I'm doing is I'm building out um, a longer form set of tutorials, which goes through each part of the system bit by bit so that you can get the entire piece put together over, let's say, 10 videos or something like that. And I'm happy to share that.